Now, question number 4, exercise 1b. Given the prime factorization of each of the following numbers, find its cube root. So part A is 21952, that is equal to 2 raised to power 6 into 7 raised to power 3. So we need to find the cube root. This is cube root. Similarly here, this is cube root. So 2 raised to power 6 into 7 raised to power 3. We can write cube root like this. So 2 raised to power 6 into 1 by 3 into 7 raised to power 3 into 1 by 3. So 3 2s are 6, 2 raised to power 2 here, and 3 1s are 3, 7 power 1. This is equal to 4 into 7, 28 is answer of the question. Now part C of this question, 287 496, that is equal to 2 raised to power 3 multiplied with 3 raised to power 3, 11 raised to power 3. So need to find cube root sign, that is equal to 2 raised to power 3, 3 raised to power 3, 11 raised to power 3 whole 1 by 3. So 2 raised to power 3 into 1 by 3, this power will be multiplied with this one. 3 raised to power 3 into 1 by 3 and 11 raised to power 3 into 1 by 3. So cancelled, this will be cancelled. So 2 into 3 into 11, 66 is the answer. Now question number 5 is, without using calculator, estimate the value of each of the following. Question number 5 is estimate the values. Part A, 66 square root. So this is approximate equal to, we can write like 64 square root. Now if you take the write the prime factorization of 8, this will be equal to approximate equal to 64. Write the prime factorization. 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So this is 2 raised to power 3, that we can write 2 into 2 into 2 into 2 into 2 into 2 6 times. So that is equal to 2 raised to power 6, and instead of square root we can write 1 by 2 power, and that is 2 6 multiplied by 1 by 2, power will be multiplied with the power. So 2 3s are 6, and this will be 2 into 2 into 2, that is equal to 8. So actually this is approximate because we took the approximate value, which is sum squared. We know that 64 is a square number of 8, so we can write this one. Question B, part B of this question, 80. We know that 81, this is very near to 81, right? 81, because 81 is square root of square of 9. So it means instead of writing all the factorization, because this is estimation, we know that these are smaller numbers, we can write this 9 into 9 and this will be square 9 square and whole power 1 by 2, and 9 square into 1 by 2, this is cancelled, equal to 9. Now the part C of the question number 5 to 18 and its cube root. So we can write 218 approximate, that is equal to approximate 216 cube root, because we know that if we multiply 6 3 times we will get 216. So 6 into 6 into 6, this is cube root, or we can write 6 3 time whole power 1 by 3, and 6 3 into 1 by 3, 3 cancelled, equal to 6. 6 is the answer. And part D, (730) cube root. So we can write that is approximate equal to 729 cube root, because 729, we know that if we multiply 9 3 times, that is equal to 9 into 9 into 9, that is equal to 729 cube root. So that is approximate equal to 9 raised to power 3 and whole power 1 by 3. So 9 3 into 1 by 3, this cancelled, so answer is 9. So this is the answer. Now question number 6 is use a calculator to evaluate each of the following, leaving your answer correct to 4 decimal places. So question number 6, part A, 7 square minus 361 divided by this is plus 21 cube. So 7 square means 7 into 7, which is 49. We can write 7 square like this, and taking square root with the calculator, square root of 361, that is 19, plus this is 21 cube. So multiply 3 times, or 21 take the cube into 21, that is equal to 9261 plus 49 minus 19, that is equal to 9291. Actually I added this term and then subtract this 19, which has negative sign. So this is the answer. Now part B of this question, which is question number 6 of exercise 1B, that is equal to 555 square root plus 5 square divided by 2 cube into 2, that is the cube root. This is cube root. Now take the square root of, with the help of calculator, square root of 555, that is equal to 23.558. The answer actually up to 4 decimal places. So this is 23.55843. I write the 5 digits after decimal right now, and this is 25, and this is equal to 2 raised to power 3, which means 2 into 2 into 2, 3 times. This is 8, and with the help of calculator, if we take the cube root of 22222, that is equal to, so I place it here, that is a shift cube root, that is 222, that is equal to 6.0550, 6.05504. So now add this 25 to 23, 25 plus 23, this will be equal to 48. So this will be 48.55843, and multiply 8 with this term. This will be 48.44039, and now divide this number by this number, 48.55843 divided by 48.44039, that is equal to 1.00, that is equal to 1.00243, and up to 4 decimal places 1.0024. We can ignore this number because this is less than 5, so this is the answer. Now part C of question number 6, part C, exercise 1b. So that is equal to 4 cube plus 4913 cube root, and then square root of whole. This is the square root. So first solve this one. Take the cube root of that is shift, this is cube root of 4913, that is equal to 17. So 43 plus answer for this is 17, and then square root. So that is equal to 4 raised to power 3 is 4 into 4 into 4, that is 64 plus 17. So 64 plus 17, that is equal to 81, and 81 is 9 into 9, or 9 square, and then square will be cancelled with the square root. So 9 is the answer. Now question number 7 is find the smallest non-zero whole number which can be multiplied by 112 to give a square number. Now question number 7, find smallest non-zero whole number which can be multiplied by 112 to give a square number. So 112, if we make the factorization of 112, that is equal to 2 5s are 10, and 2 6s are 12, 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, and 2 7s are 7 1s are. So it's 2 into 2 into 2 into 2 into 7. So for this number to be a perfect square, we know that we can write this one as 2 raised to power 2, 2 raised to power 2, this is square, this is square, and 7 has one power only. If we multiply this number by 7, for example suppose this one, then this will also be a squared number. So it means for this number to be a perfect square, we should multiply with the 7. So 7 is it should be multiplied by 7. Multiplied by 7. So this is answer. Question number 8 is find the smallest non-zero whole numbers which can be multiplied by 162 to give a cube number. So 162, it should be a cube number. So similarly, write the factorization of 162. 2 8s are 16, 2 1s are 2, 3 2s are 6, 3 7s are 21, 3 9s are 27, 3 3s are 9, 3 1s are 3. So 162, it is equal to 2 into 3 raised to power 4. 3 raised to power 4, or write 3 into 3 into 3 into 3, which is equal to 2 into 3 raised to power 4. So for this number, to make the cube this number, we must have the powers of each number multiple of 3. For example, this is 2 raised to power 1. If we multiply with 2 square, multiply with, to make a perfect cube or cube number, that it should be multiplied with 2 raised to power square. When we multiply, this will be 2 cube, and for this number to make the multiple of 3, this should be 3 raised to power 2. So now if we combine these two numbers, we will get the answer by combining this will be 2 raised to power 3, and this will be 3 raised to power 6. So it means that now this is a perfect cube. We can make this number, this is a 3 square perfect cube, or multiple of power is a multiple of 3. So now this number is a perfect cube. So it means 2 raised to power 2 and 3 raised to power 2. This is answer. Or 2 2s are 4, 3 3s are 9, equal to 36. So if we multiply this number with the 36, then this will be a cube number. So actually this answer is up to here, and you can check by you can check the answer, like if we 162 multiply with 36, that will be equal to 162 into 36, that is equal to 5832, and if we take its cube root, this is shift cube root of 5832 18. Its answer is, if you take its cube root, answer is 18. So but actually this was just check, but answer actual answer is this one, 36. Question number 9 is a textbook is opened at random without using a calculator. Find the pages the textbook is open to, given that the product of the facing number is 420. So question number 9, when a book is opened, the product is 420. For example, if we can say facing pages For example, if one page is n, then the other page or consecutive page, very next page will be n plus 1, so that is equal to 420 as per the given condition of the question. uh, Find the pages of textbook to open given that the product of facing number is 420. So let the one page is n, then the next page will be n plus 1. Also a hint is given here. Hint 400 is a perfect square. 400 is a perfect square. So it mean if 400 is a perfect square, we can, I mean that it is a perfect square of 20. So it means if we multiply 20 and next page is 21, by multiply these two number we get the 420. So if we multiply 20 into 21, next page will be n plus 1 is 21. So uh, it's, I mean that sum of these product of these two number is 420, that is equal to 420. So it means the pages will be, first page will be 20 and next will be the 21. So 20 and 21 is answer. Are pages consecutive pages, or I mean that pages after one another. So let me explain again that if open the book, let the first page is n, then the very next page will be n plus 1, and we need to write the find the pages whose product is 420. And in the book there is a also hint is given that the 400 is a perfect square. 400, that means 20 into 20 equal to 400. But we have that was just a guess point, but we need the product 420. So if we multiply 20 with 21, because if one page is 20, next will be 21, we multiply, we will get exactly 420. So it means the pages will be 20 and 21 if the product is 420. So it means the actual number of number written on the pages is 20 and 21. Next question number is question 10. The area of a square photo frame is 250 centimeters square. So squared photo frame is like this. Its area is given, that is 250 centimeters square. So area of a square, that means side multiplied by side, or s square, which is given, that is equal to 250 centimeters square. So this is area. And if we take square root of both sides, s square root and 250 centimeter square root of this one. So s side will be equal to square root of 250, that is equal to 15.81 centimeter. This is one side, that is approximate, because there is a, I take the two decimal after I mean 2 digits after decimal. So side is this one, and we need to find the perimeter of a square. Perimeter of a square is, that is equal to 4 into side. So 4 multiplied by 15.81, so that is equal to 63.25, and which is equal to 63.3 centimeter. So this is the perimeter of the square. I mean photo frame. So next question is the volume of a box in the shape of a cube is 2197 centimeter cubic. Question 11. Suppose this one is a cuboid side. So let me draw here question number 11. Let me draw the cuboid here like so actually volume of the box of the shape of cube is 2 1. So uh, volume equal to 2197 centimeter cubic. So what is the length of side of a cube? Because volume of cuboid equal to sorry, this shape actually not correct. Cube is having all the sides equal, so these are not scenes, but I mean that this is given for the cube in which all the sides are equal. So suppose one side is L, other all will be L, L, L. So if we take the cube root of this number, that is shift cube root of 2197, that is equal to 13. So length of L equal to we're taking the cube root, so this will be equal to 13 centimeter, which is one side. So if one side is 13 centimeter, then what will be the find the area of one side of the box. Area of one side, suppose this is 13, L equal to 13, and this will also be 13 centimeter. So area of one side, one face equal to area of one face equal to that will be L into L, mean 13 centimeter into 13 centimeter, that is equal to 169 centimeter square. So this is the answer of this question. Next 12 is Raju has 21 centimeter square tiles. He makes the largest square possible using some of the 20 square tiles. So total number of tiles he has 2020, and he need to make the square shape of largest possible size. How many square tiles does he have left over? Question number 12. So we need to find the greatest perfect square. Find greatest perfect square less than 2020, because total number of squares he has 2020. So I mean that number of square should not be greater than 2020, should be there is some less, no problem. If we take the square of different numbers, that for example 44, square of 44 equal to 1936, and if we take the square of 45, that is equal to 2025. So taking square of 45, that increases. We have actually 2020, so it means it is greater than 2020. So this is no possible, and for this he will use only square. I mean that make the square of, he will use this number of squares. So leftover some square will left over with him. So leftover squares equal to 2020 minus 1936. So that is equal to 84 square tiles he will left over. So this is answer. Question number 13 is, use prime factors to explain why 6 into 54 is the perfect square. 6 into 54, why it is perfect square? If we write the factorization of 6, that is 2 into 3, and factorization of 54, its factorization is 2 2s are 4, 2 7s are 14, 3 9s are 27, 3 3s are 9, 3 1s are 3. So factorization of 54, that is equal to, I write here 2 into 3 into 2 into 3 into 3 into 3. So that is equal to 2 and 2. This is 2 square and 3 square, and this is 3 square. So it means all numbers are, its factorization, all numbers are squared. So it means so because we can write, because all digits in product are squared. So 6 into 54 is a perfect square. Perfect square. Question number 14. Question number 14, part 1 is, K is non-zero whole number. Given that 6 into 54 into K is a perfect cube, write down the smallest value for K. 6 into 54 into K is a perfect cube. So write the smallest value for K. If we write the factorization of this one, that is 2 into 3, and for 54 factorization, that is 2 27s are 2, this is 3 9s are 27, 3 3s are 9, and 3 1s are 3. So that is equal to, this is 3 actually, 2 into 3 into 3 into 3. So this is 2 square, and this is 3 raised to power 4. So, and what should be the value of K so that it should be a perfect, write down the perfect cube. It should be perfect cube. For perfect cube, suppose this is K. For perfect cube, these values should have the powers 3 or multiple of 3. This is if we multiply this by 2 more, it will be I mean that what should be at K, if we multiply this with the 2, it will be 2 cube and 3 square, because to make the multiple of power multiple of 3. So it means K should be 2 into 3 square. If we multiply this number with this one by combining, actually it will be combine. If we combine this and this, or write the value of K, then this will be equal to 2 cube into 3 raised to power 6. So it means this is already cube, and this also cube. Why this cube? Because we can write 3 square cube. This is 3 square cube actually, or we can write this one, and this is so now it seems by adding the number, by adding the value of k, this became the perfect cube. So this is answer for this one. Part B is p and q are both prime numbers. Find the values of p and q so that 6 into 54 p over q is a perfect cube. Part 2 is that 6 into 54 into p over q, this is a perfect cube. So what is the value, what should be the value of p and q? As we already factorized this one, this is 2 raised to power 2, and this is 3 raised to power 4, and this is p by q. So for making perfect cube, this number should be multiplied by 2. If we multiply this with the 2, this will be 2 raised to power 3. And for this, I mean this is 3 raised to power 4. If we multiply at the place of q, if we write here 3, so 3 and power will be then reduced to 3 raised to power 3. So for example, if I write this is 2 square, and this is 3 raised to power 4. So if we write multiply this with the 2, at place of p I write the 2, and q at place of q I write 3. So it means if we write p by q, now if we solve this one, this will be 2 raised to power 3. So it means it is cube, and this will also be 3 raised to power 3, because 3 is dividing this one. So when it will shift here, it will be 3 raised to power 3. So it means so p by q should be equal to 2 by 3. So this was the actually answer, and let me explain more for this one, but answer is up to here. So that is 2 raised to power 2 into this is 3 raised to power 4. I can write 3 raised to power 3 into 3. I can break this 3 raised to power 4 and into 2 by 3. This value I wrote here. If we solve now, this 3 cancel with this 3, and now this will be equal to 2 raised to power 2 plus 1 3, and this is 3 raised to power 3. So both number are cube now. So this is just for test purpose, that I break down 3 raised to power 4 with the 3 raised to power 3 and 3 raised to power 1. 3 cancelled with this one, and I mean the number we got a perfect cube. So value of p by q, I mean that p should be equal to 2 from here, and q equal to 3. Actually this step should be here. This is just I explained extra.